Okay, a nice small group for today's evening. So that gives us enough time to answer all your questions. And from my side, again, welcome to the training. Welcome to the fundamentals training today. I don't really know if you also join the advanced one training tomorrow. So, but it's, I think I won't let you know that tomorrow is the advanced one training. Maybe it's also interesting for you. But for now, let's start with the fundamental training. Let's start with the very basic stuff. The first and important ones, this training will be recorded and you will get access afterwards. It might be, or it could take a little bit longer that you get the videos and so on. So I have to ask for your patience that, yeah, it could take 1 or 2 weeks and then you will get also the recordings. We are the trainer. I think Marcus will introduce itself. And for me, my name is Kuemmel. I'm senior Java developer. And currently, I'm the project manager of the MicroStream cluster development. And I'm also involved in some other projects on the Allianz insurance company and also on Fraport with the package concealing or package handling system. And yeah, of course, I'm also trainer and conference speaker. Yeah, and I'm your trainer for today's evening. So this is the timetable. So we started at 5. We try to have a small break around 6:30 to 6:45. It depends on the topics, and I try to set it on the right place so that it fits best somewhere between the first 2 and the last 2 lessons. The training goes to 9 o'clock, and the last lesson is a Q&A session. Okay, some further information for you. So as I already said, you will get access to the recording afterwards, and you will also get access to the code repositories of all the demo projects we're talking about. And this is exactly what I want to do. I want to share you all the links now. So be careful. There is a lot of stuff coming in within the chat. So just copy all that stuff. This includes all the GitHub repositories of EclipseStore, the EclipseStore documentation link, some training examples of my GitHub repo, and also at the end of the training, the link to the certificate. So, but I will explain that a little bit later. So questions. Feel free to ask as much questions as you can. So as I said, we are a small group. That's totally okay. Please ask whenever you want. And I think it's okay with that less people that we also use the microphone to ask. So feel free to talk with me. That's totally okay. Yeah, I already shared the links. These are the same links we talked about. And last but not least, about the certificate. So I would say around 5 to 6 days after the training, when you register on cloud.microstream.one, this is our cloud platform, just register with the same email address. That's important, with the same email address you registered to the training. So that that's important. You will see on the certificate section. So let me just share the screen. One second. I did not prepare that, so this should be the right one. Okay, here we are. So this is the cloud platform. And as I said, 5 to 6 days after the training, just register here and click on certification. And then you will see your EclipseStore, MicroStream, Fundamental, and Advanced training certificate. If you click here, you could download the certificate at the end. This is how it basically works. And as I said, around 5 or 6 days after the training. Okay. Okay, so let's go through the topics for today. So we start with a small EclipseStore introduction by Marcus. And on top of that, or after that, I do a quick demo. So that's the time for you to lean back and just have a short look to the demo. Then we do a step-by-step configuration. This is the point where you are able to code along with me. So I try to explain most of the parts and do it as slowly as possible, that you can code along in any IDE of your choice. That's totally up to you. Then we talk about the CRUD operations. So everything about create and read and update and all the stuff that databases should do. Then we go to a short introduction about a proper data model. This is always a big question we get, how to migrate from a relational database to EclipseStore, and how to create a proper data model, and yeah, what is the best practices on the data model. Then we also have to talk about queries. This is a little bit up to you. So if you are all familiar with Java streams and you use streams for a long time, then we could skip that topic. That's up to you, I have to say. Just let me know if that is interesting for you. Then we talk about lazy loading. So this is just also a small information or a small step into the lazy loading part. There is a bigger section within the advanced one training, but for the fundamentals training, it's just for you interesting. It's just interesting for you to know what is lazy loading, why is it implemented, and so on. Okay, and then we have to check the client UI and the REST interface we provide for development purposes. And yeah, that's the topics for today. And as I said, ask as many questions as you can. Okay, so that's all from my side. I would say I hand over to Marcus now. Marcus, are you ready?
Sure.
Okay, so let me just give you the rights to share your screen. Okay,
Thanks.
now you should be able to share it.
Thank you for the introduction, Christian, and welcome to our online training course of today, EclipseStore Fundamentals Training. My name is Marcus Kett. I'm CEO and co-founder of MicroStream, and I like to introduce you to the EclipseStore fundamentals and functional principles. So let's get started. Here are some information about the upcoming training courses. We have provided codes that you can use for joining us free of charge. You can enroll on the JavaPro.io, and you can enroll for free for any of these upcoming courses. So what is EclipseStore in a nutshell? So I have a new slide, so it's easier probably instead of reading text. So the EclipseStore is a data storage engine, or in other words, a persistence layer. Probably it's easier to understand as a object graph persistence engine, storage engine. So it enables you to store any kind of Java object graph, any size and any complexity of your object graph. You can use any Java types. You can design your object graph freely. So any Java objects can be stored persistently on disk or into any data storage. So any binary data storage. For instance, plain files or cloud binary object storages, blob stores like AWS S3, for instance, or any other solution that is able to store binary data persistently on disk. It allows you to store any part of your object graph. So you can store your whole object graph. You can also store just parts of your object graph persistently on disk, and vice versa. The engine allows you to load your object graph and restore it in memory when it's needed. And here also you can load and restore the whole object graph, but in practice, mostly you will just load and restore single subgraphs by using lazy loading, and to keep just hot data in memory. So it really depends on you, and you can configure it deeply. So what data and what part of your object graph you want to load and keep in memory. So it's up to you. This concept has three main benefits. First is it enables you high performance. It's because of now we are able to process data in memory with pure Java. And this is way faster than traditional databases. So it enables you to build applications that are incredible fast in memory data processing with Java. Second is lowest data storage costs in the cloud. It's because of we only need a binary data store. We don't need a traditional database anymore. Which means we just need storage. And storage in comparison to a database server is very cheap. So we save a lot of money in the cloud. And third is simplicity. It's because of the functional principle of EclipseStore is very simple. Your architecture gets very simple. The functional principle is also simple and much more simple in comparison to traditional databases or NoSQL database approaches. You can find all information under EclipseStore.io. You can find the code on GitHub and also examples how to get started, and of course also a documentation. MicroStream as a company provides you some add-ons to the EclipseStore open source project, just like indexing or a cluster solution for building distributed applications. So to learn more about how EclipseStore works, it's, I think, very important to compare it with other storage solutions on the market to understand a little bit better what are the challenges of data storage of today and why should you change it and use EclipseStore. The main problem in database programming is that the object-oriented programming languages like Java and relational databases are incompatible from a technical perspective. In Java, we are dealing with objects. Everything is object-oriented. As soon as we want to store data and we want to use a relational database, then there are challenges. It's because of it's not possible to store Java objects as they are in Java in a relational databases. So the data models are completely different. And so this is the reason why we need something in between, some transformation or conversion behind the scenes to make it possible to store objects in a relational database. The problem is well known as impedance mismatch. So you can find a lot of articles in the internet, easy to understand what the problem actually is and how it is solved today. And we have similar challenges with the modern NoSQL databases. They don't use the relational model anymore, but they now use they introduce new data models, but all of them. So no matter if you use a column store, a document store, or a key value database, a graph database, or object-oriented database, these are database-specific data models, and they are all also incompatible with the native Java object model. So we have also challenges when we want to store Java objects in these NoSQL databases, trade-offs or challenges. With relational databases, it was solved by introducing an object relational mapping. So we have to map your Java classes to tables by using an object relational mapping framework like Hibernate. So this is the idea is to store objects in a relational database. The problem with Hibernate, or one of the problems of Hibernate, is it is complex. It generates objects through every single read operation, and through every single read and write, data have to be converted, or objects have to be generated behind the scenes. And this is very time consuming. It slows down your application, slows down your query, every single query. For this reason, Hibernate integrated or allows you to use a cache, local cache, to keep data in memory. So the fastest database query is a database query you don't need, actually. So because you can fetch data directly from a hot local cache. So because of cache is way faster, it reads data, allows you to read data directly from memory. But the problem is with adding a cache, your complexity will also increase. And so it keeps your result sets in memory. And the problem is in a single JVM system, this is absolutely okay. But the problem is if you build distributed applications and there is a user to change data in the database, so this leads to data inconsistency because of if you change data in the memory of this application node, then this application node and the database are in sync. But the problem is at the same time, all the other application nodes or microservice nodes are not in sync with the database. So we have a problem here. So the complexity increases more and more. This problem is also basically fixed. So you just have to change your caching strategy, and you put cache in between of your application nodes or your microservice nodes and the database. So mostly distributed caches are used. And so we can see that the architecture gets more and more complex. And if you have, if you like to use or have a higher throughput and you have more pressure on your database nodes, you can also use a distributed database and use a database cluster. And then we have 3 clusters running, and with microservices, we have not only one distributed application, one distributed monolith. We have multiple services that scale horizontally, and so this is a common architecture of a microservice application. And here we have even multiple database systems running because of the database. The data models of the databases are limited mostly to a specific use case. So a relational database is probably not great for very complex data. Probably a graph database would be the better approach. And today with AI, we have these modern vector databases. So we probably in a big application, we will need multiple database systems. And this could be an architecture, or this is a common architecture because sometimes we also use searching servers in addition to our database systems. And so we can see a lot of machines are running, a lot of memory is used, various clusters. It's a challenge to deploy and to maintain this such a system. And keep in mind, so we are talking about stateless microservices, and we should not use big memory memory sizes, because memory is so expansive. But when we have a look behind the scenes and some levels deeper in these applications, we will see there's a distributed cache, probably there is a search server, and all of these applications are stateful. So these are stateful nodes, and then we have our monolithic database servers, and they all need a lot of memory. They all are running constantly behind the scenes. And with EclipseStore, we are now able to change this whole landscape. So this is not mandatory. You can use EclipseStore also for processing hot data, or just build a specific part of your application that needs incredible performance, and so you can include EclipseStore in your landscape. But it is also possible to replace all of these components and just use your application nodes or your microservice nodes, and use EclipseStore as a persistence layer, and you just need a blob store, and then you can simplify your whole architecture. It depends on you, and then save a lot of money. Why can you save a lot of money? It's because of storage is cheap. A cloud binary, excuse me, data storage, for instance, 250 gigabyte AWS S3 costs only $70. In comparison to PostgreSQL as a service, 250 gigabyte costs you, depending on your machine, more than $8,000 annually. If you need not that much memory, you can find probably a cheaper machine, then you can save $5,000, for instance. But at least $3,000 for really a small PostgreSQL server is a minimum. So we compare $3,000 to $73 annually. And if you need more database nodes, you need replication, then your price will double, triple, and it will skyrocket. So, and with a cloud object store, the cloud provider will care for data center replication, so you don't have to care for anything, just for $70 per year. So you can save a lot of money in the cloud if you just need a binary object store in comparison to a database. And it also works with just storage. You just need a hard disk drive and store data in plain files. This is also possible. But as I mentioned, Cloud Object Store is a great thing. It's a great product. It's managed by the cloud provider, but it depends on you. And with Java, we are now able to process data in memory with core Java features, and Java is fast. So we have a JIT compiler that accelerates your application through runtime, so constantly. And you can achieve incredible speed. We're talking about microsecond response time, and in some cases, even nanoseconds or microseconds in comparison to millisecond response time of a database. And we have a great data model. So we have objects, we have object graphs, and with object graph you can build almost everything. So you can just store single values, you can store a list, you can use collections, you can build a graph with circular references. You are able to deal with documents like JSON in memory, and we can deal with vectors in memory. So Java is great, and we have already a multi-model, a multi-data model in Java. And the only thing missing is a solution to store it. We can also filter and search object graph in memory with Java Streams. And the Java Streams API is a great query language. It's type safe. It's very fast. We have also the parallel streams for more complicated searching filter operations. And mostly searching an object graph takes only microseconds. So great performance, and this is core Java. And when we talk about microseconds, this is a factor 1,000 faster than milliseconds. So, which means research and filter time can be up to 1,000x faster than a comparable SQL or ShapeAI query. The only thing missing I mentioned is storage. So there is no way to persist Java objects. And so this is now provided by EclipseStore. And EclipseStore uses the system prevalence architectural pattern. And this is a very simple pattern or a simple architecture, which means just build a Java application and process data in memory with pure Java. Keep your data in memory. And if you really need persistence, create a snapshot of your system state and store your memory or serialize your memory to disk. This approach is not new, and this is at the same time proved architecture. For instance, investment banks are using it, or online gaming companies. So imagine you're an investment bank, and you have to build a high-frequency trading applications where you have to create a contract in microseconds or even nanoseconds because you're trading stocks at the stock market. How would you achieve this with a traditional database that provides you only a millisecond response time? So these applications are built as a huge Java monolith, and everything is executed in memory by using the core Java functionalities. And we use this functional principle for EclipseStore, but this in a very elegant way. So let's have a look how it really works. Before we get started with the functional principle, this is not a research project or a new approach where we want to find out whether this really works or not. It is bulletproof, it's stable, it is already well integrated with Helidon, which is a microservice framework driven by Oracle. And this was the very first integration with a microservice framework. So thanks to the Helidon team in Prague, who integrated MicroStream with and now EclipseStore with Helidon. And also Micronaut uses EclipseStore as a persistence approach and provides a really beautiful integration with EclipseStore. And here we can see the EclipseStore history. So the development process started more than 10 years ago, and it is really stable, bulletproof, and in production use for many years already. So, all right. So I mentioned already, EclipseStore is able to store your object graph on disk. So it creates a binary representation of your object graph and stores the binary data persistently into a binary data storage. It creates a binary representation, means we serialize the objects directly to disk. And for this purpose, we use the Eclipse serializer. So there is no Java serialization involved. So we use the Eclipse serializer to serialize the objects, and you as a developer, you decide which objects are stored and when the objects are stored and serialized to disk. And with the Eclipse serializer enables you to store just parts of your object graph. So never the whole object graph, or in practice, mostly we will never serialize the whole object graph. So just the changed objects should be serialized to disk. This is possible by using the Eclipse serializer. It is faster than Java serialization. It enables you to deal with all Java types, and you do not have to implement serializable, so you can deal with POJOs. This is the great thing. So change objects in an object graph, and you just have to call a store method, and then your object reference is serialized to disk as a binary and added to the file storage. The architecture now gets very simple because we only need storage. We only need a blob store. That's it. So here again is the architecture of the JPA architecture. So we replace the persistence framework, and we can skip the cache, because the functional principle is keep your data in memory. We do it anyway. We keep data in memory, so we don't need a local cache anymore. Replace the persistence framework and skip the local cache. Okay, and we just need a binary storage or a hard disk drive. That's it. EclipseStore runs embedded within the same JVM of your application or microservice. So it runs embedded, and your data are in memory. On our website, EclipseStore.io, you can find a performance demo. It shows you that each query is executed really fast. And here are some additional components. As I mentioned already, the Eclipse serializer is the core of this solution. And then we provide a persistence storage framework for the JVM. And there is also the same persistence framework for Android. We provide you a legacy type mapping. And this is responsible for schema changes. So you don't have to be afraid of what is when my classes change. So this is solved by legacy type mapping. So Christian will show you in more deep how this works. Then the framework provides you a file system garbage collector, because every serialized object reference is stored as a binary file appended to your file storage. And to clean up the file storage and to keep it small, there is a file system garbage collector that is responsible for cleaning up your file storage. Then we provide a file system abstraction, and this allows you to store your binary data, your persistent data anywhere. So you can choose your file, your storage target freely. You can store your binaries in a blob store or write it in a plain files on a mounted volume, for instance. Yeah, so it enables you to store your data anywhere. Then we provide database connectors. It's because of database systems, traditional database systems are able to store binaries. So MySQL database, of course, can store binaries, and this is why you can, of course, use also a traditional database to store the binary data. But keep in mind, there is no more relational model used by EclipseStore. There is no more object relational mapping. So we never create the normal records in your relational database. We just serialize your objects and store it as a binary. We provide a REST interface that allows you to get access to your storage data. So to the binary data in your storage. And on top of this REST interface, we provide you a graphical user interface that allows you to browse through your binary data in your file storage to check, to enable you to check out if there are mistakes in your file storage or something like that. So it's a very open system, and we also provide you native backup functions, converter for importing or exporting data into EclipseStore, or you can also migrate from EclipseStore to any other storage solution. And this is a really powerful package, and this is provided by EclipseStore. It runs wherever a JVM runs, so on servers, of course, on desktop machines, on your local computer, in containers, with microservices. It even runs with GraalVM native images. And the only requirement is Java version 8. So the latest EclipseStore version requires Java JDK version 11. It runs also with other JVM languages and is available, as I mentioned, on Android as well. Here is an overview about the most common database connectors we provide. And one very important hint. With EclipseStore, you keep data in memory and you process data in memory, which means you should have a lot of memory, but it is not mandatory. So this is very important at this point. If you have a terabyte memory, use it. So you can load the whole object graph and the whole database in the memory. And this will be the fastest approach because there is no more I/O operations. And so this would be extremely fast. But the problem here could be the startup time will be slow. So this approach probably will not work with microservices. So this is why EclipseStore also works with small memory sizes. So you can use it with 2 GB memory. This is absolutely fine. And it even runs with AWS Lambda, for instance, when you have only 512 MB memory. This will really work. But to be honest, the more memory you have, the better it is. But as I mentioned, So a common EclipseStore application is very fine with 1 CPU and 2 GB memory. But it depends on the use case, of course. It depends whether you want to build a monolithic Java application or microservices. You can do both. To get started, it's super easy because EclipseStore is a Java library. You can download it via Maven Central and include it in your project. The only thing you need in memory is an instance of an EclipseStore in-memory database, and you need an instance of your storage target, and you need a root object. And at this root object, you can add objects and store objects. So the root object is the starting point of your in-memory database, and all objects or object references that can be reached from this root can be persisted by EclipseStore. So here is our root object. Let's add some objects, and the only thing you have to do is to call a store method, store this object, and then it creates a binary representation of this object and serialize it to disk. So this is just one store method, and it is, so each store creates a new binary file, and this operation is an atomic all or nothing operation. So this here is a blocking operation and transaction safe. So you can add some more objects, store these objects, and we create a new binary file in our storage. So we never overwrite data. It's the same when you change an object and you store it, then a new binary file will be created and added to your file storage. Very important. What happens when we start an application? So when we start an application, then the engine loads the whole object graph structure into the memory. So it generates, of course, an instance, database instance, a root object, and then loads the whole representation of your object graph, but no data is loaded. Here are only the object IDs are loaded. So you get a fully indexed or a kind of like indexed object graph in memory. And you can define what objects should be loaded initially or should be loaded lazy when needed. So you can define it. So let's load initially some objects. For loading object reference, you just have to call a get method. That's it. There are no more classic selects. Just call a get method, get customer, for instance, and then the engine will load this customer object and will merge the object directly into your object graph. So there are no object copies. It's super convenient, fully object oriented. So you don't have to care for the result set. So there is no more classic result set. Get an object and it's merged directly into your object graph. As I mentioned, lazy loading. If you just need POJOs, so there are no requirements to your classes. And if you do nothing, then EclipseStore will load also data into memory. But if you want to define your object reference, your subgraph as lazy, then you just have to use a wrapper class, and then this object will be loaded only when you call a get method. Otherwise, there are no data loaded into the memory. So call a get method, and then the objects and the data are loaded into the memory. Otherwise, the objects are not loaded or not created. No data is loaded into memory. No objects are created in memory, and we can save memory. And this is the reason why it also works with small memory sizes. And for your existing objects, you can define a timeout, or you can remove your object from the memory if you like. So you have full control of your lazy references to save memory, or let the JVM care for memory management. So you just don't have to care for memory management. Everything is done by the JVM. But if you like, so you have full control of your lazy references. So if there are some object references that are not needed, so then just can remove it from the memory and just keep the hot data in memory. Then it works like a cache. Searching and filtering, I mentioned already, this is done with the Java Streams API. So this is common core Java stuff. And when you want to change something in your class structure, this is also trouble-free. So you can change your classes anytime. Then when MicroStream or EclipseStore loads object reference, an object in memory, it compares your object, the loaded object, with your class. And if there are some changes in your class, then the engine can solve this automatically by using a heuristic. And it works well for the simpler cases, like you add a field or you remove a field, or you change some primitive types. This can be solved by the framework itself. For more complicated cases, you can define a so-called legacy type mapping. And then you have to store your object again. So, which means you will create a new binary file in your storage. So we never overwrite change data in the file storage. Also, if you change an object, store it again, it creates a new binary file. But at this point, we will have two different versions of our object. So there will be a new version, and we can see here the red binary file. This is the old version, and which means we will have a lot of legacy files in your file storage. And to clean this up, we have this EclipseStore garbage collector that works on Firebase and removes the legacy objects from the file storage. So you can configure this garbage collector into deep and customize it for your purpose. If I/O speed is important for you, and the more memory you have and the more memory you use, I/O operations are not needed that much, probably. If you have less memory, probably there will be more I/O operations. And I/O operations, of course, are the slowest part of EclipseStore. And to make it faster, to accelerate I/O operations, EclipseStore provides you so-called channels, which are threads, and you can parallel your I/O operation by these multiple channels. The more cores you have, the more channels you can use, so you can speed up your I/O operations. So last point. So the EclipseStore open source framework, which is under EPL, by the way, enables you to get persistence for your POJOs on a single JVM, so on one application node. If you need or want to build a distributed application, then you obviously you need a replication, and this enables you, or MicroStream enables you to build this distributed EclipseStore applications and provides you with replication. All right, and so we also provide you an application cluster for horizontally scaling, and the functional principle is also easy. So if your distributed application, the load increases and your distributed application has more load, then the system will automatically start further machines with this horizontally scaling and elastic scaling process. And for that, we provide you we provide you sorry for that. We provide you an elastic scalable system. So it starts new nodes when required to share the load, and it will shut down application nodes when the load goes down to save resources. So this is the way how it works, and this is provided as a fully managed service in the cloud. And the EclipseStore cluster architecture, we can see here in this slide, is very simple. So there are only the application nodes or the microservice instances used as a EclipseStore cluster, and we have storage. We have this binary data storage. That's it. So no more caches between are required, and no more database servers. No more multiple database systems are required. So you get a plain architecture. And of course, you know, if you use it as application nodes, then these nodes have state, so they are stateful. But you can use this approach also by using the EclipseStore cluster as a data provider, and then you can also use serverless functions, stateless microservices, and call your data provider, your EclipseStore cluster, by using REST or GraphQL. Then it works from the functional principle similar to a database server. The performance will be, of course, way slower. It's because of here's wire in between, but the power of the single EclipseStore nodes are really incredible, because they are way faster. Every single node is way faster than a comparable database, traditional database. And this cluster solution is provided as a fully managed service on AWS, but you can also use it as on-prem to run it in your own cloud account or in your own hardware. So it depends on you. Here's an overview about the product landscape. The core is EclipseStore open source framework, which is source under EPL, which means you can use it for commercial purposes. There are no restrictions. You can build great products, and if you need a distributed system, you can use MicroStream cluster. There will be a new MicroStream Enterprise Edition coming up in some weeks, hopefully. Here we offer advanced search, an index API, and some other cool features. Mostly you won't need these features, but for really mission-critical enterprise applications, these features can be very interesting. Challenges with EclipseStore, we have pros and we have cons, of course. There are challenges with EclipseStore. So it's built for developers, and mostly developers we speak to, they love it. It's because of it feels Java-like. It don't feels like another database system that forces you to build your classes around the database. It enables you to store just POJOs. You can design your object model freely. That's great. So Java developers love it. So there are no more two data models, classes, and the database data models. Just only one model, just your classes, and no requirements to your classes. But there are challenges, which means it's a completely different approach. So it's a paradigm shift in database programming. So you have to forget everything you have ever heard about how a server database works. And you can also not compare it with a NoSQL database, because it is not a NoSQL database. So keep this in mind. It works different. It is a storage engine. It runs within your application. Your data are in your application. You search and filter in your application by your business logic. There is no database that cares for concurrency. So they use the Java features, use the Java methods for dealing with concurrency. So everything we need to process data is provided by Java. You have to use the Java features, not database features, because there is no more database system. Which means also there is no SQL support, no SQL support. So you cannot send just a query from everywhere. You cannot send a query, an SQL query from everywhere to your in-memory database. This is impossible. You have to define an interface, and you have to provide an interface for that to allow third-party application get access to your data. That's actually the way to go. But and this is you will build a great architecture and how you should do, but it's different. So it's not a database management system. Your business logic has to care for validation, concurrency, as I mentioned. But we can do it in Java, and we can do it better. So this is the reason why we have not planned to provide you such features and force you to use these database features. So Java is better. And unfortunately, or fortunately, I don't know. So it's not suited for DBAs. The application is under full control of the Java developer. There is nothing to do for a DBA because everything is done in the Java source code. There are no more database tools. So this can be a challenge for your organization. This might not be a technical challenge or a problem, but this can be a challenge in terms of your organization. So keep this in mind. So this is built for Java only. This is only also not a problem actually. So because we're all Java developers, but so this is not built and suited for .NET or for Python. It's a Java approach. And it is not a drop-in replacement. So sometimes users, their expectation is, can I use it as a drop-in replacement and to replace my relational database with just some mouse clicks? And the answer is no. Unfortunately, no, this is not a drop-in replacement. You have to migrate your application. This is not a big deal. So you can keep all your classes, and you will redesign some of your classes probably and make it more elegant, but you have to do it, or you should do it in practice. So there is a migration effort. As an end result, you get an awesome, fast, and easy to maintain pure Java application but keep in mind there is migration effort. All right. I'm pretty sure Christian is already waiting for to continue with the Getting Started workshop. Again, if you're interested in some further courses, you can enroll for free. So take this chance. We have new codes provided by the JavaPro magazine, and they are sponsored by MicroStream. So check it out and join us. Thank you for joining the intro. And now I'd like to hand over to Christian again. If you have any questions, take the chance, ask the questions. We're here to answer your questions today. Thank you.
Thank you, Marcus. Yay. So let me just organize my screen a little bit. So I need to see the chat. Here we are, and you, okay. Now, so yeah, as Marcus said, if there are any questions, feel free to ask. And during the time, I want to share a performance demonstration with you. So we always talk about performance, and I think it's quite interesting to see what we are talking about. So when we talk about performance, we prepared an architecture that looks like this. So that means we set up 3 EC2 instances. Don't ask me about how much CPU and RAM we have there. So yeah, so what I could say is that these 2 EC2 instances are the same CPU and RAM. About this one, I don't really know. So, and we set up these EC2 instances. On the left side, there is on both sides a Micronaut application is running, one with EclipseStore and one with Hibernate, with a Hibernate implementation, and with some REST endpoints. And there are on the right side, there is a PostgreSQL on the same EC2 instance. So that means we write down data directly to the instance itself. And it's the same on the left side. We use EclipseStore and we store the data directly to that EC2 instance. And with the sender application, we send requests and we measure the amount of requests we are able to do. We measure the amount of CPU usage and RAM and access time and so on. And I think that's the architecture of the demonstration. And I already started that this application. So let me just, we don't need that anymore. And I started the sender application with that small body application. And as you can see here, there is, it's just a book endpoint. And this book, that book endpoint returns 1,500 books with title and value and author and ISBN. It's a standardized REST call, nothing special in it. And it returns that 1,500 books again and again. And this is basically what happened. And now we measure that on a Grafana dashboard, and this is the result for the. It's already up and running. It runs for several minutes now, and now you could see the differences. So. We are limited to 1,200 requests per second, I guess. Yes, and that is not really important. So, more important is the difference on the response time, and you see that Postgre needs 172 milliseconds for a request compared to MicroStream with 2.98 milliseconds per request. So it's an insane, MicroStream is insane, much more faster than PostgreSQL. And what also is interesting is we see the CPU on the PostgreSQL side and the CPU on the MicroStream side. Now, so this is quite interesting, that amount of performance you get when you use an in-memory technology like EclipseStore. Now you might say, okay, that's not a fair comparison. A relational database is mostly slower than some other technologies. But an interesting question is, and you might also say, okay, that MicroStream is working in memory instead of PostgreSQL is working on the hard disk, and this is actually wrong, because PostgreSQL is using a cache on the Hibernate side. So that means the second level cache is up and running. So even PostgreSQL and even Hibernate is using the cache to provide performance, I would say. But then is the question, why is it that slow compared to MicroStream? And the point is, or compared to EclipseStore, the point is that object mapping is slows down the process enormous. So it's only the object relational mapping in between. So the conversion from the relational structure to the Java structure, that is insane slow, and that makes those differences. We could start a second comparison. So let me just stop this application and see what happened when we force both applications to use only lazy. That means we deactivate the cache functionality on the PostgreSQL on the Hibernate side, and we also deactivate or we using lazy loading on the MicroStream side. And let's see what the differences are. So both applications are working directly from the hard disk. So data is loaded again and again. So, and we call that lazy. That example is a lazy call, and it needs a little bit on startup to see those things. But at the beginning, we see, okay, we have basically 100 millisecond compared to 350 millisecond on the Postgre side. You see both applications are doing heavyweight input-output stuff. And that's the reason why we have that high CPU usage on both sides. Also, MicroStream needs to load the data all the time from the hard disk, and that is leading to a huge CPU consumption. So, but you see, or you could see a lot the differences on the request or on the response time. We have 100 milliseconds compared to 350 around. So this is what it means when we talk about performance. And yeah, I think that's okay to see that. If you are interested in, we are able to share that example here if you want to test it on your side. Okay, so that's the thing of performance. So let's move on. How this is working. So let's jump in. I hope you could see my screen, and it's okay for you to read it. You should be able to read the code, and that is important. Is that okay for you? So I changed the resolution to full HD, so that means it should work, I would say. Let me just double check what's wrong here. Okay, so it's not available for now. Okay, so I want to start with a small basic example project, and I will start in the same way that the documentation does. That means we try to have a look on the very basic getting started example. That's the moment where you could lean back and just have a look how it basically works. So as I said, I created a normal Maven project, basic example. It's not necessary that you check out this or something else. It's not part of the GitHub repository. And the first thing we have to do is we have to add some dependencies to use EclipseStore within your project. It's also already, or it's the same way explained in the getting started section here. And what we need is the dependency here. This is the one and most important one, I would say. There is another one which is also important. I'd like to share this with you directly. So we use the storage embedded. That's the one we need the storage embedded version 1.3.2. Especially when you use Java 21, it's recommended to use the 1.3.2 because there is a big issue or a big bug, I would say, within any version lower than 1.3.2, and we fixed that in that version. And there is a second one, which is also quite helpful, and it's named storage.embedded.configuration. So that's the second one. And I think these are the two most important dependencies we need when we work with EclipseStore. The first one is the main dependency, and the second one gives you the ability to do some configuration stuff on EclipseStore. And there are a lot more dependencies, and you could find all these dependencies within our documentation. There is a list of all the different modules we provide. Yeah, and as I already explained, the storage itself, storage embedded, we talked about storage embedded configuration, a lot of different modules we provide. Okay, so let's move on. So we added our two dependencies. We used Java 17 in that case. I upgraded it a few minutes ago. Hopefully that will run. Okay, so we have the dependencies, and now we switch directly to the main method. And the only thing we need, the first step is we need an object which is called Embedded Storage Manager. And let's call this the database management service, I would say. Whenever this storage manager starts up, the database is working and running. And there is a quick version to initialize a storage manager like this. We could directly call the start method, and that's it. So we have that storage manager is the instance of the storage itself. One important thing is each storage manager, the database itself, the storage manager itself, needs one root object on top. It's kind of like an entrance object to the graph. And in this example here, I just used a simple single string object because it's an object as all the other objects. So I added that string, and in this case, I call the store root method. It's not always good to call this. We are talking about this later on. But in that specific case, it makes sense to call a store method, which is called store root. That means we store that root object because it has changed in that specific case, and that's it. So, okay, so, and that's it. This is the only code we need to start with EclipseStore. So what we could do now is you could have a short look to the left here. You see there is no data folder and no storage folder somewhere. And now when I call that main method, so I would do this run as Java application. I missed the storage manager shutdown. Give me just a second. In this case, I need the shutdown method, but it's also okay. And now you see that storage folder appears on the left here. That means the storage is created on my hard disk, and you see there is one channel 0 folder, and there is a persistence tag dictionary. Let's jump into this. Show in System Explorer. Here we are. So this is what the storage looks like at the end, and most of the time it looks like this. Marcus already explained the topic regarding the different channels. It's possible to have multiple channels for multiple input-output threads to write down the data multi-threaded in a multi-threaded way. In my case, I just use one channel, and just to give you an idea, the persistent type dictionary is the type dictionary that contains the different objects of your object graph, I would say, or all the objects you are able to store within EclipseStore. So it contains the object ID itself, and it contains, so just a second, I'd like to share this with you. Yeah, it looks like this. So persistent type dictionary, and as you see, there are all the different Java data types that are supported by EclipseStore, and directly down there should be, yeah, the string one should be somewhere here. And the important thing is this is the type ID, and the type ID identifies the Java data type within the binary storage. Okay, and there is the channel file, and the channel file contains the data itself. It's a binary format. There is another transaction file, but this is only used within the storage itself. Okay, so this is how it is stored at the end. And whenever we start the storage itself, it will be recreated. So if it's not existing, so at the end, let me just start this again. Run as Java application. You see the storage is recreated. When we do a refresh, here is it, and it's created all the time. So, and we set the root hello world, and we don't have to store it at the end. So, and just so as I said, it's already created, and now we should see the hello world down here in the console. Let me just clear that, and let's start it again and see what happened. Okay, let's see. Here it is. You see that the string is stored, so I restarted the application itself, and it means it's stored at the end. But this is just a really basic example of that. Let's do some more extended version on that. So you might ask, okay, does that really need to be a string or need a different object? So we no longer need this. We have to deactivate this one. Okay, let's start with my company object. My company in that case is here. So, and we could have a short look on that. So my company consists of a list of books, and maybe I have to change that a little bit because there are no books in it so far. I think I missed that. Yeah, we need to change that. Let's change this to customer, so that makes more sense. So we need customers at the end, so we call this get customers. So now it's customers, and okay, now this will work. So okay, let's jump back. So let's initialize my company object. So I already said, okay, this is my root object, my entrance to the object graph. And in the next step, I have to create the embedded storage manager. We already did that before. This is a little bit more extended way. So I said, okay, this is my root object, and in that case, I changed the file directory a little bit. Then I have to create customer entities, my domain objects. So let's jump into the customer to give you an idea what's in it. So a customer consists of a male and name and first name and age. Nothing special, a really straightforward, normal Java class. Nothing special in it. There are no annotation needed so far, like in Hibernate or in other persistent frameworks. So we created those customers, and then we use our root objects. So we say my company is the root. Give me the customer. Give me the customers, and I just edit or I add the customer at the end. Okay, that's nothing special. At the end, I have to store my changes. So I added some customers, and this is the first very important thing when I explain EclipseStore. You always have to store the object which has changed. So in our case, the the company or the get customers collection, so the collection of customers in that case has changed. And that's also the reason why I have to change, or I have to store the collection itself. And that's the reason why I store the customers itself. Normally, you are used to store the object which has added to the storage with an insert or stuff like that. And this is a little bit changing when you handle EclipseStore, or when you use EclipseStore. In that case, you have to store the object which has changed, because this is the object, or this is the reference holder at the end. Okay, so okay, let me double check if everything is all right. So we created the root object, an embedded storage manager. Let me delete the old storage. We no longer need this. Okay, we created the customers, we added them, and we store them. This is needed a little bit later, and then after that we shut down. Okay, so that's it. Let's start. Okay, let's double check if this is created. Let's refresh. Okay, you see, it changed a little bit. Now it's called data, but it's created. That's fine. So the application is stopped. And now we don't need this middle part anymore. So because we don't want to create these customers again, we just want to have the customer at the end. So let's add that system print line. And that's it. So let's start. And now we should see the customers at the end within our console. Now, and this is exactly what happened here. John Doe and my email address. And that's a good opportunity. If you have any questions after the training, just send me a mail. And I will do my best to answer that. Okay. Yeah, that's it. I would say there is nothing more at the beginning to explain how EclipseStore works. It's that easy. Just a few lines of code. You are able to create one root object. It could be a business object, like in my case. So let's say we have a company, but it could also be a synthetical root object. Let's call it root, whatever. The important thing is that root contains all the lists and all the collections which should be stored within the storage itself, but especially for the data structure, we talk about a little bit later. Okay, any questions so far? So that's a really straightforward demonstration, just to show you how easy it is to use EclipseStore at the end. Any questions from your side? Okay. So then I would say let's move on. As I already explained, there is I prepared a hands-on demo, and that gives you the opportunity to code along with me. And let's switch to it. So first, let me share you that project. It is called step-by-step configuration. So that means it's one project with multiple branches in it, and so that enables you to code with me together. And if there is if something goes wrong, you could directly change to the next branch, and it will work after. It's a Micronaut project, but let me explain that a little bit later in more detail. So this is the come on, no, I don't cancel this. So this is the project itself. So just check it out in your IDE. So as I said, use any IDE of your choice. There is one important thing, because it's a Micronaut project, you have to enable the annotation processing within your IDE. So in my case, that means, so give me just a second. I need to move that I need to put that down there. Okay. So in my case, that means, so when I go to the preferences of Eclipse, there is one point which is called Maven here. And within that Maven, you find that annotation processing. And I think on IntelliJ, it's the same. It's also, you could also find it on the Maven part. And then you have to enable annotation processing. That's important. Without that, the application will not run at the end. So you can directly start on the step-by-step configuration one beginning branch. That's the branch we directly start. And yeah, as I said, you could stay on that branch till the end. We will do everything on that branch. And if something goes wrong, or you're not able to follow, just switch the branch to the next step, and that will enable you to stay along with me or to stay with me. Okay, so give me just a second. I have to wrap up my UI a little bit. Okay. So I give you some more seconds or minutes to check out the project itself. So when you are at this branch, when you will be able to start the application. So there is one class in it, which is called application.java. And to have this is totally enough. So the Micronaut version itself, it's a really old one, but it's not that important for those examples within my training. But when you check out the application on that branch, it might be possible that you have to do a Maven build first. That could help. But after that, you will be able to just run this application class as a Java application. And it should look like this. So it tells you Micronaut is up and running, startup completed within some certain milliseconds, and you will find a server, in my case, on localhost 8080. And when I call this localhost 8080, it looks like this. Page not found, and this is totally okay because there are no controller classes in it so far. But I think it's okay to see that Micronaut is up and running, and that's it. The reason why I use Micronaut within the training is because sometimes it makes sense to store data, to load data, to see the result, so in some cases I had to create some UIs to see the data, and Micronaut helps me to create those REST endpoints, and that makes totally sense, especially for the training. Then we could see the data within the browser and so on, and we are able to call those methods within the browser. Okay, you're good to go so far? Are we able to start? This project is Java 17 project, but we will have a look later to the POM XML. Okay, so let's start. So the first thing we have to do is we have to add the dependencies of EclipseStore. This is so let's step into the POM XML. And so as I said, it's Java 17 here, and let's add the dependencies at the end. So we see we have the two dependencies, the storage embedded dependency and the storage embedded configuration. In that case, we need both. So because we want to configure that a little bit. So it makes sense to have these two dependencies. Let me just paste that directly to the chat. So if you need the dependencies, just copy it directly from the chat. It makes things a little bit easier for you. Okay, this is the current version, 1.3.2. And that's all we have to do within the POM XML. Okay, so let's move on. Okay, so we need some packages, some more packages down here. And you might wondering why I initialized things not in the correct way, like Micronaut, like you are used to use it within Micronaut. For me, it's more important to explain the EclipseStore stuff at the end and not the microstream and not the Micronaut stuff. So don't hesitate me. This is not the way how to work with Micronaut. I just try to keep it as simple as possible. Okay, so we need one class which is called DB. In my case, I created that class just to hold the reference to the embedded storage foundation and so on. So this is my database initializer class, I would call it. And as I already explained, this class contains the storage manager at the one hand. So let's create it. So let's say public static, let's say public static, and it's called embedded storage manager. Come on, no, it's wrong. Okay, and let's call it storage manager. So we need one instance of the storage manager at the end. And we need a second instance of our root object, right? So this is what we basically need. So, and that means, so let's create one. So let's create another class and let's call it data root. So this is my, the entrance object to the object graph itself. And we call it data root. And it's okay to have it empty or to leave it empty for now. But let's create an instance here, static. Let's call it also final static data root. And let's call it root, and let's create a direct instance of that. So that's it. Okay, and last but not least, we need one static initializer block here within the DB class, just to ensure whenever we touch the DB class the first time, that all stuff gets initialized at the end. And let's call our storage manager here equals, and now we use the embedded storage configuration. So this is the reason why we added that configuration module, and that provides us a builder pattern to do the initialization of the embedded storage manager or the storage manager itself. So we use the builder pattern, and now we could set the storage directory, and let's call it data. So this is the data folder. Then let's say set channel count. So we want to write down the data within 2 threads. And I would recommend, in my experience, a sweet spot for those channel counts is something between 1 and 4. That's totally enough. For most of the projects, I would say. Okay, set channel count. We could do some further adjustments, but that's okay with that. So we set the storage directory and the channel count. And the next step we have to do is we have to create an embedded storage foundation. That's always the case. So that means so there are 3 steps, I would say: creating a configuration, Out of that configuration, you create a foundation. And based on that foundation, you will be able to create a storage manager at the end. So dot create a storage manager. Now, and you might miss one. So we need to set the root also. We could do this when we create the embedded storage manager. So add the root object here as a parameter. And after that, we have to call start. And that's it. So that's important to call the start method at the end. So that means whenever we touch the DB class the first time, so the embedded storage manager gets started and it uses the root object for initialization. Okay, so again, just to summarize that a little bit, we used the embedded storage configuration builder pattern to do some configuration. Out of that configuration, we create an embedded storage foundation. And after that, we create an embedded storage manager. We hand over the root object, which is created up here. And after that, we call the start method. That's it. So that means whenever we touch the DB class, it will be initialized at the beginning. Okay, so let's move on. That's okay. So now I'm on the branch 5, create entity and register those entities. So I create another package here. Let's call it domain.domain. And within that package, I create a class which is named, let me just check. Oh, there are 2 of them. So I need a book entity. So new Java class, let's create book. Here we are. And another one, which is called author. Here we are. Author. 2 domain objects, a book and author. And as I said, we are okay so far with that. But that brings me directly to the data root again. So we need to store those books somewhere. So we need a collection with books. Author will be a sub-object of books at the end. Each book has one author. That's okay for now. But we need a collection somewhere to handle or to hold all our books. And that is the reason why I create a list of books within my data root. So let's create one. So let's say private final list. We use the Java utils list. We type that list to books or to book, and let's call it books equals new array list. And let's say book. Okay, so here we are. Let's import the right one, the microstream domain book. We need some get and set methods. They are not really needed, get and set methods. And you could also use Lombok for that. That is totally okay for EclipseStore. You could use whatever you want. In my case, I'm used to use some get and sets, and that's okay for me. Yeah, that's it. And as I said, let's jump into the book object itself. Let's create some fields here. So let's say private string ISBN. Then let's add another one. Let's call it name. And we need a third one. Let's call it author. As I already explained, there is one sub-entity or sub-object, which is called author, and that's it. So that's all we need. create get and set methods, generate. Okay, so that's these are the fields of a book itself. Let's jump into the author object. And let's create some fields also there. So let's say private string mail and some more mail and first name and last name. Get and sets, just get methods. That's okay. The only thing I forgot now is we have to create some extended constructors, and therefore I use create constructor using fields. It looks like this. So because later the code I create authors directly within the constructor, and that's why I add those that constructor. So on both classes using fields, here we are. Feel free to copy the code also from the GitHub. It's totally okay. You don't have to type that. Okay, so we created most of the stuff we need for EclipseStore. So we have our domain objects. We initialize the DB, the storage manager at the end. We created a data root with a list of books at the end. Our application, it's available anyway. So, and next, last but not least, we need a controller class. And that brings me to the last branch, number 6, controller create books done. And therefore, I create another package here, which is called controller. And I create a class there, which is called book controller. So, and there are two methods in it. So first we have to add the controller annotation, controller of slash books. So that means whenever we call localhost.8080/books, we get into this specific controller. And as I said, we need two methods. The first one, which is called public, we return an HTTP response. The first one, HTTP response, and let's add a string, and we call it create books. So that's the first method. And yeah, as I said, it's not the right way to do it, especially the annotations here. It's normally not a get at the end, but I try to keep it as simple as possible, and especially for the training, and that enables you to call that that interface directly from the browser. So, and therefore I choose the get all the time. So even when we create something here. So we are okay with that. Okay, so I share the code with you directly. So I post it to the chat. So just copy it, because it's a lot of stuff we have to type here. And I just copy all that stuff directly to the class. So that means we need to import those books. Okay, so here we are. So we create 2 authors and 4 books, and we add the authors directly to the book at the end within the constructor. And then we call the static DB class .db.root get books and add all. So this is common Java stuff here. And the interesting part comes down here at line 26, the DB storage manager.store. And as I already explained, we have to store the instance which has changed, and it's the book collection at the end. And that's why I added db.root to .getBooks. At the end, we have to return an HTTP response. Okay, book successfully created. That's all we need. And because of that, we add another method. It looks like this. I also share this with you within the chat. It's a normal get with a list. It returns a list of books. And we just return db.root getBooks. That's it. That's quite easy and straightforward. Here we are. Okay, let me summarize that a little bit. We created a DB class just to provide the instance of an embedded storage manager. I did it in a static way. I know it's not the right way to do this within Micronaut, but it's okay for the training, I would say. We need a data root as an entrance point to the object graph. I created two domain classes, book and author. And at the end, we need one controller class to get access to the data at the end. And yeah, that's it. So let's check it out. It should run. So that means let's move to the application class and let's start this as a Java application. And you see Micronaut up and running, localhost 8080. And when I now call localhost 8080, it should look like, okay. So you might have to do a Maven update before, or a Maven build, clean package, I would say, because we changed the POM XML. And therefore we have to start it again. No. Something is wrong so far. What's happened? It's not running as expected. So did I miss something? DB page. No. 8080. The port is also okay. Maybe it's the update of. Let's check it out. So step by step, let's do another Maven update. Maybe that helps. Okay. Okay, I see. Okay, that's what that was. That's called books. Okay, now it's working. So I forgot to add the /books at the end of localhost 8080/books, because that's the entrance point of our controller class. And when we call books, we directly forward it to this get method here. And so do you remember I told you whenever we touch the DB class, the database will be initialized, and that happens here. So that means EclipseStore starts up and initialized all the data, but for now it's empty. There are no data in it, and that brings me to the next point. So let me just call /book/create. That's the second method, and I get the message back: book successfully created. That's it. And when we now check the books again, you should see the created books at the end. Does that work so far on your side? Just remember, you have to enable the annotation processing. That's important. Without that annotation processing, this will not work. And the second point is you have to do a Maven clean package to start the application. And sometimes it makes sense to run it on a different port. For those of you, when 8080 is still in use, sometimes that could be also a problem. So let me know if something doesn't work as expected. So then we try to fix that. All good. That's great. Okay, so works okay. That's great. So let's restart that application. You know, the data should be available within. So let's just double check if there is something created on our hard disk. So let's refresh it, and you should see the data folder on the left with the 2 channel files at the end. And when we now restart the application, we don't need the creation anymore. So we could directly call. Did I close it? So we could directly call localhost 8080/books, and the data should be there without any creation, so on. So you see, that's the proof of the persistence, that the data is still there, and this is how it basically works. Okay, great. So let's have a short look to the topics. So we talked about the introduction, we did a quick demonstration, we created the step-by-step configuration. Let's move on with the CRUD operations, and after that with a proper data model. I think that are the most important things in the second part. I'd like to skip the Java streams a little bit. So I try to accelerate the topics a little bit, and I think it's okay to skip that. Is there any one of you who never worked with Java Streams API or is not aware of Java Streams so far? It is an interesting and important topic, especially for EclipseStore, because the Java Streams is the way how to load and filter data at the end. There is no query language so far, and therefore Java Streams is important, but I think most of the Java developers are aware of Java Streams, I guess. Okay, so let's move on. Let's talk about the CRUD stuff. I created a project, so let me share this with you. So that is the link to the project itself, and there is one branch which is called CRUD implementation done, and we could directly jump into that branch. And I did it. I did the same here. So I'm directly in the end. Normally, this is also a hands-on stuff, but let's do it. Just have a short look to the controller itself. Let me just summarize the project a little bit. So I created the storage embedded in the same way, I would say. So, oh no, it's a little bit different. So in that specific case, I used an XML file to configure MicroStream and EclipseStore. I used this XML file with the channel count, storage directory. It's a different way to initialize, but it's not that important for now. So I created a data root with books. It's the same like in the other projects. We have our books and authors. As I said, it's the same. And there is a mockup utils. So that means, this project contains 2 JSON files, one books JSON file, and this JSON file consists of around 1,000 books. And there are also some authors. and there is a controller class at the end to store these files. And that brings me directly to the controller class, and that's the important one. And let's go through these methods here and just talk a little bit why we choose the store methods like this, and let's talk about that CRUD methods at the end. Okay, we start at the create, and we already did that in the example before. On line 27, it's an add all. It's a common Java method, Java collection method add all, and it's the same on the store, and I have to repeat it. So we added something to a collection, and with that action, we changed the collection itself, and that means we have to store the collection itself, and that's the reason why we call db.root.getBooks. That's how it works. So you always have to store the object which has changed. Let's move on to the create single method. We already did that in the same way. So we created author books, we add some book, and that's it. Nothing special. Let's move on. Get books is the same. Now this could be a little bit more interesting. Starts with an A. That's an example how to query the data. And this is, yeah, I would say, yeah, this is how the Streams API works. So in my opinion, when I have to explain the Streams API, it consists of three different types or it's a three-type structure, I would say. At the beginning, we have the streams keyword. That's the first. Every stream starts with a stream or parallel stream keyword. Then we have a condition in the middle, mostly starts with filter, and it contains a condition here. And at the end, we have the definition of what we want to have back. And in that case, we will get a list of books that starts with an A. This is how the Streams API basically works. And yeah, that is how it is used within EclipseStore by searching for specific elements within the collection. Okay, clearing books. That's interesting. That's the first thing we want to talk when we want to delete something. So, but it's also really straightforward. So we clear the collection itself, and after that we store the collection. It's easy as it could be. So not a big deal. So we delete something. Update a single one. And this is now this is a situation that changed a little bit. So there is one book. In that case, we stream to find a first one, just one example book to change it. We change the set release date to local date.now. And after that, as I explained, we have to store the object which has changed. And in that case, it's the book itself. And then we have to store the book. Next thing is update multi-books, and this is a little bit different than the other stuff, and that's interesting to know, because we had to implement kind of like a transactional behavior at the end, and therefore we created two different methods. One you can see here in line 80, and it's the create eager storer method, and there is another one which is called, let's say, storer. Let's call ls equals db.storagemanager.create lazy storer. And then this is quite interesting because these are two different storers, and the one in line 81 is the default one. So whenever you call the store method like here, so in line 72, you always use the lazy storer. And lazy storing means you only store the object which has changed and without any sub-objects. That means, let's say you have a book object, and a book object consists of some strings and in addition an author object, and you change something within the author object, it will not be stored when you use the lazy storer. The the lazy store stores only the main object which is handovered to that method. And that's the difference to the eager store. The eager store stores everything, including all the objects below a specific one. So when you change the author, and maybe let's say the author consists of some additional sub-entities, all these entities will be stored at the end. And that makes the eager store sometimes a little bit dangerous, because you have to understand how the storing works in the background. So whenever you call a store method, you always append the edited data, you always append it to the binary file at the end. And there is let's call it housekeeping process that is working in the background, and it deletes the double entries within the storage at the end. That means whenever you use the eager store, the whole object and its sub-objects will be added at the end to the storage. And that could be a really big issue. For example, let's say we store the root object itself with an eager store. That means the whole storage will be attached to the end of the binary file. That's not the best way to do it, but that explains why we have those different storers at the end. Sometimes it makes sense to use the eager store, but you have to be aware that the eager store stores everything below, stores everything, the object which is handovered itself and all the sub-entities below. And the lazy store stores only the handovered object. And that's the difference between these two storers. So in that case, so let's choose the lazy store, because it makes more sense to do that. And now you could see we stream through that books starts with an A, and for each book within that stream, we change the price of that book. So you see that for each book, called it B, and B get price dot multiply, and that's so we calculate a new price, and at the end we say B dot set price value. And the store object itself works like a transactional behavior. That means we could say ls lazy store dot store ls. That means you register the object within the lazy store at the end, and after you stream through the whole book collection, you could say ls dot commit. And this is the point where the objects are stored to the persistence at the end. So, and with that functionality, it's kind of like a transactional behavior. You will be able to put this within a try-catch or stuff like that. That is totally up to you, but that gives you the possibility to have a transactional thing at the end. On the advanced one training, you will see how to roll back data. This is also possible. So that means it's always possible to roll back that elements which are inside that lazy store. Okay, so lazy store, eager store, that's important to know. Both are usable. The default is the lazy store, and yeah, that's how the CRUD CRUD functionality is basically working. So let's summarize that. Creating books, so adding stuff to a collection, nothing special. We already talked about that. Just storing the collections itself. For loading objects, we use the Streams API. For clearing something, just remove the object from a collection and store the collection again. That's it. And whenever you change an object, you have to store the object itself. In that case, it's the book. And last but not least, the two different storer methods, create lazy store, create eager store. And we talked about the differences, and that's it. And at the end, you call ls.commit, and the data goes directly to the hard disk. Okay, any questions so far regarding the CRUD operation? It's really nothing really complicated at the end. Yeah. Yes, you are totally right. So now this is how it should be. So let me just commit that. So because it's the second time I had that error within the training. So give me just a second. That makes totally sense to push it directly. Is that okay? So just a second. So right here. So this is. I did not change that data root. Did I change something here? Okay. It's a different project. So okay. CRUD operations. Here we are. Okay, that looks good. Okay. Let's go to change. Okay, so now we are good to go. So let's talk about a proper data model. So the point, some of our customers are always asked, okay, what is best practice to migrate a relational database to EclipseStore, how to use it, what is the best practice to create a data model. And I prepared a small presentation for that, just to give you an idea how this could work at the end. Okay, so let's imagine we are a book selling company. So let's say Amazon or something else with multiple bookstores, and we are selling thousands of books a day to our customer. What most important nodes or / tables do we need, and how the relations would look like? And let's go through. So of course we need one company object on top of that. And this company has an address, of course. We have multiple stores and we have some customers. And the store itself, each store has a range of books or a list of books. Each store has a range of orders, some employees, addresses, and also a customer has an address, of course. Each book has an author, orders, and each book has an author. Oh, this is wrong. So a book has also images maybe, and order details and address and so on. So the structure could look like this in a way, maybe some differences, whatever. So let's say it is this structure. So when we now look at a relational database, we normally would create some tables based on that. So we need a table for the company, maybe. So we need a table for books, a table for authors, a table for stores, for customers, and so on. For each domain object, we normally create a table. So this is what basically happens when you use a relational database. One table for images and so on. On the Hibernate side, you create a data structure that looks like this. So my company, address, store, customers, and so on. This is barely the same we see in the slide before. A book with author and images. And now you see the differences of the structure. So we always have to map this structure to that Hibernate structure. But also, these things are different because we choose the best from both sides for MicroStream. On the left side, we choose the tables as a collection, but I would say, yeah, half of the amount of tables that we have before. So of course, when we want to store books, we need to have a collection that holds the books at the end. So, but especially for authors, as an example, each book has its own author. That means we don't need a list of authors at the end, but we talk about this a little bit later. So that means we choose the same tables that we need normally in a relational database, and we create collections on that. But not every domain object needs its own collection because it's part of the sub entity, for example. And we choose from the left, we choose the relations, the fields, and the validators. So we don't need those Hibernate annotations and stuff like that. We just choose the relations itself. And in some parts, we create a data model that looks like the result set at the end when we call a select on a relational database. For example, when we create a select on the books, it might be possible that we get authors and images at the same time, because when, let's say, these are eager relations, for example, or eager references, then when you create a select on books, you will get authors at the end and images. And it's the same on customer and address. And that's the difference between the relational database and Hibernate, and both compared to EclipseStore, because we choose, on the one side, we choose the tables as a structure, as collections, and on the other side, we choose the same structure that we get when we stream through a result set, right? So this is the differences, I would say, or this is the way we work. That means at the end, we use powerful collections, lists, sets, and maps, and later on maybe the gigamap and many more other possibilities. And you have to create a data structure like you build a data model for a cache, for example. So let's think about, you create a data model, or you think about you could rely on a 24/7 availability of your application. You don't have to restart your application at any time. So, and just imagine we don't need a persistent storage anymore. So let's just use the Java application as database. It never restarts, and let's build a data structure exactly for that. And this is how to build a data model for EclipseStore. To be more precisely, there are some things you have to consider. The first one, where are all my tables? That means, that's what I explained. We only need half the amount of tables or collections at the end compared to the relational database at the end. Because we have that sub entities and that objects below any other object. But you always have to consider what happens if I delete an object. So one example is an author, for example. What if we have our books and each book has its own author? But what happens if we delete the last book of a specific author? Then the author itself is gone. That means when you want to create a combo box, for example, to show all the authors of your books, you will lose that specific author because you don't have that author anymore, because it was part of the book itself. And when you delete the book, the author is also gone. So in that specific case, you will need a collection of authors and the authors within the book to have that. But we'll talk about that a little bit later. Always a question is, what about indices? Or let's talk about primary keys, foreign keys, and stuff like that. Basically, you will not need those primary keys anymore, especially the synthetical ones. So that means we don't need a primary key, which is an integer, for example, or an increasing integer value, or a UUID, or whatever. Basically, you will not need that anymore, but you will need unique identifier. Of course, you need to find your data at the end, And it could be an ISBN for a book or an email address for a person or whatever. So just use unique identifiers at the end, but it's not needed to have synthetical ones. So I would say a famous example of that is orders and order details. Mostly there is no identifier of a detail row of a specific orders, right? There is an ID 1, 2, and 3, but you need a second part to assign a specific detail row to a specific order. And most of the time people use order detail, foreign key or primary key, stuff like that. This is no longer necessary, because now in that structure we use, the detail is directly a part of the order object itself. So the order object contains a list of order details. And so a primary key is no longer needed because we have our object references at the end. Is there something else than list and set? We talk about that. What about bidirectionals? We also talk about that. And there are many more things you have to consider at the end. And based on that, let's do a small example. So we are still on our company, on our book company, and I choose the basic example just to give you an idea what's going on. So no, let me just. Okay, let's start with a book entity, right? So we want to store books. So we create a book entity, and the first thing we have to talk about is, do we need an ID or a primary key? I already explained that. Normally we don't need it, but we need an identifier, and it makes sense to say private, come on, this one, private string ISBN. So that's all we need, because the ISBN should be unique, and it's totally okay for an identifier. Sometimes it makes sense to have stuff like this. So it could make sense, say private string UID equals UUID dot random dot toString. So this is what we do sometimes when we really need a special identifier UID. We use that random UID within EclipseStore, especially on our projects on Allianz or on Fraport. So when we really need a synthetical one, we use the UUID functionality. That works great, and we are totally fine with that. Okay, but we need to store those books, right? So we decided, okay, we created a book, we added some fields, we added our identifier, and this is the point where we have to store this within my company. And now let's do that. We need to add book here and call it books, and let's import that. Oh, come on. So I think that's now here we are. So let's create a get method for that. Okay, so we need to store those books in a list to have that. Okay, easy. The question is, what about my company? So the company itself is our root object, right? So we store everything that belongs to the root. We store it to the company. That means this class could also consist of private string, let's call it company name, or company name. It looks like this. So that means my root object can also contain normal objects or normal values, or primitives or whatever, everything that belongs to the company. So each book we talked about has its own author, right? So let's say private string author. Not string, sorry, author, and let's call it author. So each book has its own author. So let's create that author object. That's okay. So let's add a name, for example, private string name. Okay, so what is the problem here? So I already explained that a little bit. So what happened if the last book of that collection of the, where we are, data root, oh, that's the wrong one, we don't need that anymore. So here we are. So what happened if the last book is sold, maybe, then the author is gone. In that case, it could make sense to have a second list of authors, for example. Oh, and let's call it author. Oh, come on. Authors. So that could make sense to have that. The problem is, people always ask, does that double the memory at the end? So what do you think? Does that double the memory? So when we add an author and we have an author here, no, that's exactly. It doesn't, because it's only a reference. And you need only the amount of RAM for the reference itself, but not for the object within. And that's a great solution. But there is another problem. So here we are able to add the same author twice, right? So we could add Stephen King and another Stephen King object. And this should not be the case. That we have to take care about that. But when we want to have a unique list where each entry can only appears once, then we choose a set. And it makes more sense to do that. Just use Java objects, Java collections itself, and the functionality of Java collections to choose the right data structure for your needs. And that's one of the biggest advantages of EclipseStore. In the past, you always built a data structure which fits best to your database. But now you will be able to create the best data structure for your needs within your application. And that's a big advantage at the end. So, okay, so we choose a set of authors, that each author can only be once here in it. And we have a second author, and there is another big advantage. When we change an author here, all these authors within the books are also changed at the end, because it's a reference. So that works really great at the end. Okay, so what about images? What if we need to have images, but how do we store images? There are two different possibilities. So let's say we could create another collection here. Let's call it, what is it? Is it a binary? I have to check that. What is the data type here? We could use just a second. I have to double check the come on. What is here we are. Just a second. I missed something. Okay, now it's byte. Yeah, makes sense. What or a byte array. So let's do it like this. Okay, this could be one possibility to store the images, but the problem is you might say, okay, how to find at the end the right image? So especially when we talk about relational databases itself, so you always have to find an index for your bytes and for your images, and this is by far not the best way to store images. So let's say, okay, we do not use this one. We make it different. So we store the images directly within the book object itself. So each book consists of its own or has its own images at the end. So let me just copy this. So let's add it here. So that makes totally more sense to have it here. That prevents you from having big, huge lists of your bytes and images. But it's the same. It's a better way to store images, but not the best, I would say. There are some more improvements that could be done here. Instead of, let's say there are 10 images and you're searching for a specific one. Maybe one image is the cover of the book and the other ones are it's an image of, whatever. So then we could create another, a better structure. Let's use a map instead of a set. Let's say a map, we use string as a self-made index, for example, and then we have our byte at the end, our byte array at the end. Images2 equals new hash map, and that's it. So and now things are going to be more interesting at the end, because this is an opportunity you will not have within your database. There is no map structure within a relational database normally, and that gives you so much more possibilities to create a data structure that is really great. But at the end, you could do this, for example, storing your images. I would never recommend to doing that. Most of the time, it's best to store bytes somewhere on a byte storage like AWS S3, for example. It makes totally more sense instead of having this within your database at the end. Okay, but there are possibilities to store it, and it depends on the collection type itself, and it makes more sense to have that this way. And this is one reason why I told you that you will not have that much tables at the end, like on a relational database in EclipseStore. Okay, so let's move on. Okay, we talked about an index. So that's and I think this example gives the answer to us. For example, it's in let's say we have millions of books. Here we are. So we choose a list at the beginning, but does it make more sense to use a different data structure instead of a list? So let's say we create a private final map. Let's add a string as a key, and let's add a list of books. Books2 equals new hash map. Sorry. Oh. Would look like this. A map. You might say, okay, what is the string here? So let's say books books by ISBN. Yeah, let's say first 4 digits, or the first 4 digits of the ISBN. So that gives you an index. You're searching for the very first 4 digits of the ISBN, and then you can directly step into your books. But there are some more possibilities. Let's copy this. Another one could be author. This could also be an index, right? So using authors for indexing your books. Books by author. And you see, there are thousands of different ideas how to create a proper data structure at the end that fits best to your needs. And the good news is, at the end, you will have, it does not doubles the data at the end. So we could have thousands of those maps in the end. The amount of storage within your RAM stays mostly the same, except the references itself. Of course, it doubles the references itself, but not the data at the end. But we talk about lazy loading at the end anyway. Okay, is that okay for you? Just to give you an idea what is possible within your data structure. So, and especially with a solution like this, you don't have to stream through your whole books all the time when you're searching for a specific one. Just use a map, and that gives you the possibility to find the map by far better than streaming through the whole list. Okay, any questions to the data structure itself? I think I covered most of the things you have to consider. There is another topic regarding lazy loading, but you will see lazy loading matches the same structure like here. For example, people always ask, let's say, when we have stuff like, oh no, let's talk about this later. So it's another topic. Okay, does that sounds good to you? That's right. This way we are, you are responsible for indexing ourselves instead of the database. But in my opinion, that makes totally sense that the index is on you, because you know what are the application needs at the end. And it makes totally more sense to say, okay, let's create an index based on that. And you always have to consider that the indexes that we used on a relational database are mostly no longer needed within EclipseStore, because, as I explained, for example, the author, the book consists of an author or has its own author, for example. So that means tables which are part of your relational database, you always have to search within, and then you need an index. But the data structure itself indexes the objects by themselves, because, for example, we don't need a whole collection of orders anymore, because an order belongs to a customer itself. And in that case, the customer itself is the index itself for the orders of that customer. And in that case, it's no longer necessary to create an index on that, because your data structure itself is the index at the end. And you will not need that much indexes at the end because of the data structure itself. And that's the differences between a relational data model and a Java data model. In some cases, it's necessary, of course, but not that much like in a relational database. Okay, so let's have a short look to the topics. Okay, I said I skip the Java Streams API a little bit it's no longer needed. And that brings me to lazy loading. And at the end, the client UI. Let's directly jump into the presentation. So I already explained that the lazy loading in detail is covered by the advanced 1 training. But we could have a short look into a presentation for lazy loading and how lazy loading works, basically, directly here. Okay, so cool, lazy loading. Okay, yeah, topics are not that important for now, so let's directly jump in. So the question is why lazy references are basically important. So EclipseStore is an in-memory database or an in-memory database framework, and that is the reason why it is so fast and performant. So that's for sure, and that's quite clear. That means you will get the best performance, or for best performance, the data must be in the RAM. So that's no surprise. But in some cases, it's impossible to hold the data, especially when binary data comes into play. I think that's a famous example to having binary data. You do not need binary data at the end within your RAM. That's for sure. And sometimes it's just unnecessary to hold all the data inside the RAM. It's the same, especially when we talk about historical data or archive data or something like that. That's an interesting point, by the way. That always happens when we doing some migration projects with EclipseStore, and a lot of people ask us, okay, what about, so we have 4 terabytes or 5 terabytes of data within our storage. And the first question, what I always ask is, do you really need all the data all the time within the focus of your, let's say, of the people that uses that data? So is it important to have the data all the time within your database? And then I ask, okay, what about binary data? Why not to store binary data to an AWS S3 bucket, for example? It makes totally much more sense to have it directly on a binary storage instead of having that within your data, within the database. And there are 2 reasons for that. The first reason is when you have it in your database, you always have to stream the data through your application server. And it's a heavyweight data which goes through your application server, and this is not needed. So just put it on an AWS S3, for example, and you can directly call it via a specific URL, for example, and the data goes from the binary storage directly to your application and not through your application server at the end. That's one reason. And the second one is, having those data is quite expensive. And also, especially relational databases with a lot of storage in it is expensive, and it's much cheaper to have it on binary storage at the end. That's one part. So when we take all the binary data, documents, images, whatever else, and move it to a different storage at the end, we have only 1 terabyte left, for example. Next step would be, do you really need all the normal data in focus? What about only to have the last 5 years of the data? And every night there is a method which moves data from the normal data to an archive data storage, for example, which is also much cheaper than a normal database. And with a method or with a functionality like that, you will decrease the amount of data which is really the important ones or which is needed all the time to small ones, and you prevent your database from scaling all the time. So when you move data every night to an archive, you don't have to take care about scaling your data all the time or scaling your database all the time, because it scales automatically. And that's that are things you should consider when you want to evaluate EclipseStore. You should choose the right storage for your really needs. And EclipseStore makes sense to have it for your main data, for your focus data, because when we talk about an application server, for example, the more concurrent user you have on your application server, the more data is loaded from the database to the application server. That means that this type of data is in memory anyway. So you have to load it anyway to your application server. Why not to have EclipseStore as an in-memory database instead of that on your application server? That makes more sense because you don't have to transfer the data from the database to the application server. Okay, but these are all some ideas and thoughts about that. That mostly comes into play when people ask, okay, is it really possible to have 5 terabytes of data within EclipseStore? And I would say, no, it doesn't make sense because most of that terabytes of data are not made to store it in memory. That doesn't make sense. And if yes, if it is necessary, I guess you have enough money to build your you have to have enough RAM at the end. By the way, do you know what is the maximum amount of RAM and CPU you get on an EC2 instance now? That's quite interesting. I hope I get it right now, but it's for the moment the biggest EC2 you could order is 448 cores and not 128 terabytes of RAM. That's the biggest EC2 you could order. That is insane, I would say. So you see, scaling is not a big problem for now. Okay, so let's jump back to lazy references at the end. In case of we do not use lazy loading, it works like this. On startup, let's imagine we have 100 million objects, for example. When we start up EclipseStore, you will have 100 million objects within your RAM. And the amount of RAM is so the, how to say, the ratio, is that the right word for that? 1 to 1.5, I would say. It's not, it depends on the type of data, but normally when we have 4 gigabytes of data on the hard disk, you will have 4 gigabytes and a little bit more within your RAM. So this is how it is the ratio at the end. Okay, but so we are able to set some lazy points within your object model. And lazy points means we use a lazy wrapper class. And we still have that 100 million objects. And with those lazy points at the end, you will get a result that looks like this. We only have 500,000 objects. But that means when we call lazy get on that point, then the data will be loaded, and it loads 6 and 7 also when 1 is loaded, but 4 stays on the hard disk. So this is how to explain the structure of using lazy. And there are some recommendations. And I already explained something on that. When to use lazy loading. I would recommend always on binary data, blobs, documents, images. We talked about that. Always on huge collections with less frequented data. So I talk about logs and archive data and stuff like that. Only things that are used once a month or once a week. Use lazy for that. Sometimes on collection with huge amounts of sub-entities. That could be possible. Then it also makes sense to use lazy loading on the object itself. So that means when you have such huge objects, then you have to make a decision. Okay, there is a master set of data, and the master contains a detail set. So the very, very important fields are part of the master. And the details which are not needed all the time you could add a lazy reference instead of that. But I come to that later. And whenever you want, if performance isn't that important in this part of data model, or the amount of RAM is limited. Okay, let's have a look how it basically works. So I already explained that lazy is kind of like a wrapper object. And in that case, we use the lazy object itself with the type of the byte array. So that's the easiest way to store images, for example. By far not the best way, I would say. I would recommend stuff like this. So creating an index or a way to search for a specific byte array. And you only have to add some, that lazy point in front as a data type. At the end, when you want to unpackage the lazy reference, you have to call the get method at the end. Huge collections, for example, let's say lazy list of books. That's an okay solution, I would say. This is best practice for most low and medium sized collections. You have to consider that whenever you stream through the books here, you always have to load the list at the end. And that's, I would not say it's a problem, but it is as it is. So, and now you have to make the decision, does it make sense to have it like this? At the end, the books will stay within your RAM anyway, because the default behavior of release lazy loaded data of EclipseStore is 30 minutes. So that means if a lazy object which is loaded stays untouched for 30 minutes, it's automatically released from the RAM. And now, you have to make a decision to say, okay, if every 30 minutes some users call these lists here, the book stays in the RAM anyway. So you don't have to create a lazy list on that. But it's a good example to see how to initialize a list or an array list like this. So with lazy.reference, and then you are able to initialize that. This makes more sense, in my opinion, having a hash map with a string as an index. Let's say the very first or the very first, some important fields to search within, and then having a list of books that prevents you from loading the whole books at once. In that case, you will only be able to choose one chunk of books, I would say. And this is just an explanation about how is the default behavior of the clearance of a lazy reference. Whenever you call the clear method at the end, you will be able to do that by yourself. Then you have to wait for the garbage collection, of course, but the clears the reference and at the end. Or you use the default behavior of EclipseStore. This is after 30 minutes, if the object stays untouched, or when you reach 75% of the memory at the end. Then EclipseStore starts to release the lazy references. And to give you an idea what's upcoming next, we are working on a new collection type, which is called GigaMap. And this GigaMap is working really great. So it's under development for now and under testing, but we will release this within our enterprise framework, and that gives you an enormous amount of possibilities to create indexes and so on. That collection, or this collection, will be really great at the end. Okay. So that's it regarding lazy loading. As I explained, we will have a more detailed look into lazy loading within the Advanced 1 training tomorrow. That's just the basic information for you to try it out, I would say. Okay, any questions so far? So that brings me to the last topic. Oh, come on, last but not least. Sorry. Okay, so I'm back again. Let's move to the last topic for today. The client UI or the REST interface. The reason why we built that feature is a lot of people have problems to use EclipseStore because they said it's hard to see the data at the end. So when you work with normal databases, you will always be able to open a front end, and then you will see the data at the end, and to see what happened inside the database. You see the data and you can scroll through it and stuff like that. And this is not the case really with EclipseStore. In my experience, I never used that REST interface because I always create my own, within the project, I always create my own preview, I would say. That means when we create UIs, you see the data within your UI. So you see what's going on in my database. And it's the same when we create Micronaut applications. I create some demo or development REST endpoints to see what's going on in my database. But especially for when you have problems seeing the data or you want to know what's going on, we created those REST interfaces. And you see that you will find that topic within the storage section, especially here, the REST interface. And there is a REST API, and you have to choose the setup and the REST API and the client UI. And I want you to share this with you because it's not that easy to activate, and sometimes some parts could go wrong at the end. Okay, so I prepared a project which is called Client UI. Let me just share you the GitHub repository. Here we are. Okay, that's the project itself. So client UI. The special thing within that project is it contains some more dependencies within the POM.XML. So we see that there is the storage embedded here. That's the normal one, the storage embedded configuration. We already knew this. But there is another one which is called a dependency storage REST service Spark Java. That's a dependency from EclipseStore. This has to be part of the POM.XML at the end, and you have to enable that REST endpoint after initialization of the storage itself. That means this should be part of your DB. So somewhere you have to start the storage REST service, and you have to hand over the storage manager, and you have to start the service. So that means, let me just do that. So there is no storage within. So no, let's start this. application up and running. Let's double check that everything works as expected. So let's say localhost books. You see the database is initialized, nothing special. Let's create some books. Okay, that's it. So that means there are a lot of books in it. 1,000 around, I would say. Okay, so now what to do? So we have to download the client UI application. So we leave the application up and running here. That's important. And come on, where's the documentation? Here we are. Okay, you have to download the UI application with that link. And after that, you have to start the application using that command here. So I already did that before. So let me just move to my downloads folder. So just check this. Here we are. Hopefully this is the right one. Okay, so we could use sometimes it's not that easy to use the PowerShell at the end. So let's do it like this. So okay, now I have to copy. Just a second, I will show you that afterwards. So did I do the download so far? So it is the download again. Okay, so okay, so you see that? So I downloaded the jar file and I started the jar file directly from the console with the method java -jar storage REST client app standalone assembly and so on. And that brings me to the point where I can open it. You could use this link to open it at the end. And now this is the client UI. So it's a small application just to provide you access. The important thing is this application has to run. That's important. So, and then it has the normal storage data in it. That's the link to the client. And then that enables you to connect to the client. And now you could see the data at the end in a different structure than you already know, because this is the object structure itself. That means you could open it, you see the books in it, you see the object ID. And this is especially the object ID. There are two IDs. That's the most important one, IDs of your storage itself. It's the object ID. It identifies an object itself, and it's the type ID. It identifies the type of a specific object. And you see that here, and you see the different types below, and you could see what happens inside a specific object. That could be quite helpful, especially when you're starting to use EclipseStore. It makes sense to have this application up and running. And but I would recommend to or I have to recommend, you have to disable this on production. This is only for development purposes. This is not for use in production at the end. Okay, and this is how it basically works. This is the client UI. It helps a lot, and we are still working on the client UI to improve the functionality. This is only a few of the data. You will not be able to change the data within that UI. That's also important. And you will have, in addition, some more statistics, the file count, the size of the storage, the files itself, and so on. There is a lot of different information within it, and we are still working to improve these UI, but sometimes it's not that easier, and it's not because yeah, you always have to find you have to how to say, yeah, not important. So so what I want to say is we're still improving that, and yeah, we will see what happened in the next time. Okay, any questions so far? Thank you. No, thanks. Okay, great. So that brings me to the end of the fundamentals training. We talked about basic introduction, a quick demonstration. We talked about configuration, CRUD operations, the data model itself, and how to work with it. We skipped the Java Streams API for good reasons, I would say. Lazy loading we talked about, and at the end, the client UI. I think that's it for now. As I said, just wait 5 or 6 days. You will find a certificate at the end. Yeah, if there are no further questions, we are at the end, I would say. Thank you for joining the fundamentals training. Hope it was interesting to you. Hopefully I see you tomorrow in the advanced training. And yeah, enjoy EclipseStore and let me know if there are further questions. Send me an email. I try to do my best to answer it. Thank you.